My name is David Conigliaro. I'm the Mill product line manager at CNC Software. I've been employed here for 11 years, but I've been involved with the Mastercam product for over 20 years, since 1996, 1997. We developed the model chamfer toolpath with ease of use and efficiency in mind. We're trying to give our users a toolpath that will let them get the code they need in hand faster and safer. So the model chamfer toolpath is gouge-free against the solid model you're chamfering, as well as any fixture components. You can select fixture components and other solids on the screen, and you can assign additional clearance values. The equal scallop in Mastercam 2019 is a powerful toolpath. We have scallop technology in Mastercam. This is not an incremental improvement. This is completely different. We felt we had to go a complete different direction to get what we wanted, so we created the equal scallop. It's going to create superior point separation. It's going to create superior finishes. The equal scallop toolpath is less likely to create wavy motion, which is pretty common in scallop toolpaths across the industry. And it will also tend to not want to create noise in the toolpaths. In Mastercam 2019, we've implemented a projected boundary smoothing tolerance on the toolpath control page for our hybrid toolpath and our new equal scallop. This tolerance will be applied to your tool containment boundary after it's been projected down onto the 3D model. That projection step at times can introduce some wave and noise in the boundary, especially if you're trying to project a boundary down a very steep feature or along a sharp corner. You can turn on projected boundary smoothing tolerance, put in a value, and Mastercam will take that projected boundary result and it will smooth out the noise. In Mastercam 2019, we've taken our check holder add-on functionality and we implement it directly into the product. So I can now take a mill toolpath within Mastercam 2019, launch the check holder utility. I can run that check and see if my shank and holder are within a certain distance of my model. If they are, the check holder utility will suggest an alternate tool stick out length, a longer one. I can take that information and go edit that operation and have confidence that I'm not going to gouge. Or I can tell the check holder utility to do that edit for me automatically.
Mastercam 2019 adds a check holder function to the Mill Toolpaths utility group. You can use this function to calculate a safe minimum tool projection for all your mill toolpaths. The new check holder function calculates areas in the toolpath where there is interference between the holder and the part. It then tells you the minimum tool length needed to avoid collision with the holder. This is a great utility to use when you do not want to modify the toolpath, for example, trimming it to avoid collisions. You simply want to adjust the tool length to make sure that the holder clears the part. The equal scallop toolpath in our part file has great tool motion, but backplot shows the holder gouging the part as it moves down the steep walls. In this video, we use check holder to modify the equal scallop toolpath by modifying the tool. Other options include creating a new tool for the existing toolpath, or creating an entirely new toolpath operation, which adds a new tool automatically. Set up the criteria for the collision test by entering a resolution of 0.1. This value adjusts the grid spacing Mastercam uses to check for holder interference. Smaller numbers give more accurate results. Higher numbers speed up processing. Set the tolerance to 0.005. This defines the accuracy of the test. Enter 0.25 for holder clearance and leave the shank clearance at 0. Click Perform Test to begin the analysis. When the analysis is complete, Mastercam displays the results in the graphics window. Safe tool motion displays in blue, and the red tool motion shows where the holder does not clear the part. The collision test results section of the dialog shows that to prevent the holder interference, a minimum tool projection is needed. The tool projection field also updates to the same minimum value. You can edit the tool projection and then click OK to save your changes. Now we will run backplot to see the new tool length and verify that the holder has proper clearance. Check holder is an easy way to test for holder interference and quickly adjust tool projection for safe clearance. Mastercam 2019 introduces Model Chamfer, a new 2D toolpath. Model Chamfer allows you to machine safe horizontal chamfers on solid models. The Model Chamfer toolpath is in the 2D gallery on the Mill Toolpaths Contextual tab. Model Chamfer accepts solid edges and faces as chain geometry. Once you have selected your chain geometry, the Model Chamfer toolpath will populate the solid model parameter with the solid models that the chain geometry came from. A new dialog box will display, informing you of the number of solid models currently selected for the toolpath. You can enter a side clearance, which is the distance from the solid model that you want the vertical part of your flute to clear. Use avoidance model to select surfaces, solids, or meshes to avoid when machining. Enter a clearance value to further the distance between the tool and the selected avoidance models. Model Chamfer requires you to use a chamfer mill tool type. Model Chamfer also includes options to control your cut parameters. Enter a chamfer width value, allowing Mastercam to measure the width from the chain geometry, adjusted by the cut depth defined on the linking parameter page. Use the top offset to define how far the full diameter of the tool is above the top rail of the chamfer. Use the bottom offset to define how far the tip of the tool is from the bottom of the chamfer. These offsets are helpful when your chain geometry is the top or bottom rail of the chamfered edge. Model Chamfer simplifies machining chamfer features on solid models. The solid models can have either sharp corners or solid chamfers modeled in. The Model Chamfer toolpath handles both scenarios. Mastercam 2019 introduces a new 3D high-speed toolpath called Equal Scallop. This new toolpath creates a consistent scallop motion relative to the step-over distance. Equal Scallop is located in the 3D gallery on the Mill Toolpaths Contextual tab. Like other 3D high-speed toolpaths, the model geometry page allows you to select machining geometry and avoidance geometry. Equal Scallop also offers some additional options on the cut parameters page. You can select spiral, which eliminates step-overs while machining. You can also select smoothing, which will attempt to smooth sharp corners and replace them with curves. This results in a more even load on the tool and lets you consistently maintain a higher feed rate. Compared to the 3D high-speed scallop toolpath, Equal Scallop produces a superior surface finish. With Equal Scallop, there are no sharp corners when machining this feature. When using 3D high-speed scallop, you can see that there are sharp corners. When both toolpaths are displayed, you can see the difference in how the feature is machined. Equal scallop produces more efficient point separation and is more free-flowing while generating less noise, especially near steep features and corners smaller than the tool radius. Use Mastercam's new Equal Scallop toolpath to create superior finishes and smoother motion. While this is an evolution of our scallop cutting, the original scallop toolpath is still available for those jobs that work best with it. In Mastercam 2019, accelerated finishing has been extended to support new circle segment tool geometries. In addition to barrel form tools, Mastercam now supports lens form and taper form tools. Circle segment tool profiles include multiple radius segments as well as large radius segments on cutting edges, which can deliver faster results with a better finish. A lens form tool includes a large radius segment across the tooltip in addition to smaller corner radii. The large radius segment lets the tool engage more of the stock and shallow areas of your part, resulting in smaller cusps and increased step over. Taper form tools include 4 circular segments. In addition to the ball tip and radii at the top and bottom of the taper, the tapered segment itself is a large radius circular segment. This lets the tool more effectively engage part walls and steep areas of your part, resulting in much more efficient multi-axis toolpaths. Compare the results of machining the same feature with a traditional ball end mill and a taper form mill. When you machine this area with a ball end mill, you see that you need a very small step over, resulting in many cutting passes. The maximum step over is only 0.03 of an inch. When you machine the same part feature with a taper form mill, you can see that the tool engages the part much more effectively, resulting in significantly fewer cutting passes. The step over between each pass is 0.25 of an inch, dramatically reducing the machining time. Even with a larger step over, circular segment tool geometry results in smaller cusps for a better finish. The more efficient cutting passes also greatly improve tool life. In previous versions of Mastercam, when selecting point geometry for a toolpath, the drill point selection dialog box would display. In Mastercam 2019, the drill point selection dialog box has been replaced with a toolpath hole definition function panel. Functions that were located on the previous dialog box are still available with the new function panel, such as mask on arc, subprograms, and sorting. The features list displays all the currently selected features. You can use general selection practices to select features to machine, such as window selection. You can also select or deselect points manually. All the changes are live. The options below the features list allow you to select points differently, such as by using mask on arc or copy previous points. You can also move features up and down in the list. Mask on arc allows you to select the center points of arcs with matching diameters. This is helpful for parts with many holes, all with different diameters. Select mask on arc and then select an arc. You can window select the part file and Mastercam will only select the center points of arcs with the same diameter. In this part file, you can see that only the blue arcs have been selected. All the other arcs have been ignored as they do not have the same diameter. The Change Parameters at Point option displays an overlay, allowing you to set parameters specific to the selected points. You can change general settings, add can text, or alter coolant settings. Depth filters located under the Features list allows you to filter out points with the same x-y coordinates but have different z heights. When Depth Filters is deselected, all features are selected regardless of their z height. By selecting Depth Filters and setting it to Use Highest Z Depth, only selected entities at the highest z depth are kept and the rest are filtered out. Use the Sort options to select a sorting pattern that makes the most sense for the point layout in your part. The red point indicates where Mastercam attempts to set the start point. After you have selected a sort method, the relevant options will expand in the function panel. Use these options to further control the selected sorting method. You can also set a tolerance, which determines if a sorted point belongs in the same column as the first sorted point, or if it belongs in the next column. The Toolpath Hole Definition function panel and new selection workflow gives you a smooth modern selection method with live sorting and preview. Mastercam 2019 adds a projected containment boundary smoothing tolerance to equal scallop and hybrid 3D high-speed toolpaths. Using this new tolerance can significantly smooth and improve the consistency of toolpath passes. This is particularly beneficial for moving the tool down steep walls and when compensating to the inside of a containment boundary on a cavity or the outside of a containment boundary on a boss. You will find the projected boundary smoothing tolerance setting on the toolpath control page for hybrid and equal scallop 3D high-speed toolpaths. This equal scallop toolpath was created without using a projected boundary smoothing tolerance. Notice that the toolpath is choppy and noisy along the corners of the lower walls. Here is another equal scallop toolpath that uses all of the same parameters with one exception. Projected boundary smoothing tolerance is selected and is set to 0.05. Notice that the toolpath motion is now much smoother and more consistent. By simply turning on this feature in your hybrid and equal scallop operations, you can greatly improve the quality of the resulting toolpaths.